Hey everyone, welcome to the final video of the first part of our course. Today we are going to finally learn how to create an actual real deep neural network. It will build on the previous videos and it's important to make sure that you have understood everything that came so far, but today we are going to take only one very simple step that is going to accomplish what we want. We are going to add a deep layer to our neural network, and it's going to allow us to model a much more interesting and complicated patterns. A single layer neural network can do a lot, but deep neural network can model pretty much anything you can imagine. And in many datasets, it is necessary to have one or more deep layers because it allows us to pick up on the patterns that are too complex for a single layer neural network. So how are we going to do this? Well, it's very simple. We have already learned how to make a neural network with several inputs and several outputs, and all we need to do is to stack two of those on top of each other. So what we are going to do is to take our first neural network, and we are going to use its outputs, these nodes, as the inputs of the second neural network. In practice, all that means is that we will have to do the matrix vector multiplication 2 times. It will be surprisingly simple. You will see it once we jump over to the code. So this is just going to be two consecutive matrix vector multiplications, and it will accomplish that. But before we do this, first let's learn some terminology. The first column of the neurons that we see here are called inputs. The last one is called outputs or predictions, and this everything in between them, whether it's one column or two, there can be many layers, and they're called deep layers. Sometimes they are also called hidden layers. And the second thing that I want to tell you is that the numbers that these neurons output, they are called activations sometimes, because neural networks are modeled on how real brain works, and in real brain neurons accept multiple inputs and then they activate when they cross some threshold. We haven't learned anything about activations yet because right now we are just doing weighted sums, but in the future there will be a special activation function that will modify this number based on some math formula. We don't need to worry about this now. I'm just going to tell you that instead of calling them outputs, like we used to call these inputs and these outputs, every number that a neuron calculates is going to be called activation. Alright, excellent. Now we are ready to jump over to code and see how it works in practice. Very well. First we will move on very quickly and I will just copy some code from the previous tutorials so that you wouldn't be bored watching me type it. And the first thing we want to do is to define our data. It will be the data about the flower species again because it's a great example to use. As always, we define our different features, different measurements of the flower, and put them into a list of inputs. Next we are going to need to define our weights. Again, the first part of it will be identical to the previous videos. I'm just copy pasting it from the previous tutorial, except the variable will be called not just weights but input hidden weights. Input and hidden means that these are the weights that are between the input layer and the output layer. So all of those weights in this area are weights between input and hidden layer. And just like that, we will define a second variable, second weight matrix. Again, consider that enough. All of the weights are completely made up. In the future we will learn them and calculate them automatically. Now I've just made them up with trial and error. This variable will be called hidden and output weights, and as you can probably guess, identically these are the weights between the hidden layer and the output layer. Sweet. And the final thing we need to do is to create a weights variable that will contain all of those, and it will just be a list. First element of it will be the first set of weights, second element of it will be the second set of weights. Great. Next step is as always defining our ANN. Here I will take you through this. It will be surprisingly simple and your mind will be blown by how similar it is to what we have done previously. As always, we will define an ANN function that will accept our inputs and weights. Here we will first want to calculate the weights of the deep hidden layer, of this layer. So if you ignore all of this part of the neural network, we will just do the identical thing and calculate these three activations. To do that, we are just going to create a variable called hidden that will contain their activations, and as before we will use np dot function to calculate a dot product, and it will accept the weights, except that this time, because weights are put into a bigger array, we will need to take the first element of this array to make sure that we are taking this variable, that is this set of weights. And we will do the dot product with inputs. Exactly what we had done in the previous video. Let's make a little comment. Predict the activations of the deep hidden layer. Sweet. So the mystery here is how will we calculate the second set of activation. Well, if you ignore the first part of the neural network, you just can imagine that these three nodes are now inputs. So whatever they have calculated are now inputs, and we will pass them to the second neural network. So we will just create a variable called prediction. Actually, predictions doesn't matter. So that it will contain the last layer of our neural network, and to calculate them, we will do exactly the same thing. NP dot except we are going to use weights from the second set of weights, from this one, completely separately defined matrix of weights, and instead of inputs, we will pass a hidden layer to it. Hidden. So this variable will first calculate the hidden layer, and then this variable will take hidden layer as input and calculate our predictions. And we will return them as always. Return predictions. Sweet. And finally, all we need to do is to use this neural network to make our predictions. Again, the code is identical to the previous tutorial, so I will just copy and paste it. We are going to create a prediction variable, use our neural network, and print out the results. Ta-da! It works exactly like this, except that now our model is much more complex and much more capable of calculating a much more interesting and sophisticated patterns. And as you can probably imagine, let's not forget to make a little bit of a comment here. Predict the outputs of the neural network. Excellent, excellent. So that's it. As you can imagine, you can probably do this as many times as you want. If you want to have two hidden layers, you will just create a hidden layer, hidden one. It will accept the hidden layer, and it will accept hidden layer, a set of weights, and then prediction would use the hidden, let's call it hidden 2 layer, and the third set of weights. I haven't defined it, so the code doesn't work. I just want to give you the idea that you can do this as many times as you want, and that way you will be able to create as many layers as you want, and that will allow you to create arbitrarily complex models. Excellent. So this is what I wanted to tell you about in this part of the course. Let's do a quick summary. We have went from making the simplest neuron that will just multiply, that was able only to just multiply one input by one weight to make one prediction. We have learned how to make predictions based on multiple inputs. We have learned how to make multiple predictions based on multiple inputs, and finally we have learned how to stack them together to make a real deep neural network. Huzzah! So, to predict, neural networks perform repeated weighted sums of the input. That part is important to understand. And this very limited and simple set of concepts that we have just learned are responsible for creating arbitrarily advanced neural networks. Of course, there are different architectures and stuff, but basically what we have learned is enough to create a neural network. And the intelligence of the neural network, that is the quality of its predictions, will depend on the weights. How to figure them out is a mystery that we will discover in the second part of the course. Everything we have done so far is also called forward propagation. This is another concept that I wanted to tell you about, and it simply means that our neural network takes an input data and propagates it forward. So it takes data from here, it propagates it forward to the next layer propagates it forward to the next layer. In the future, we will learn about something called backward propagation that will propagate information in the reverse direction in order to train the previous layers. But it's a subject for a separate video. Excellent. So, what we will see in the next section? Well, we will learn how to set weights. We will learn how to train neural networks and actually make it figure out the patterns and learn on itself to make accurate predictions. And you will see that just as in this section, all of the complexity was made out of very simple concepts. The process of training neural networks is also made out of very simple ideas that we will stack together to make something powerful and very, very interesting. I hope this course is interesting and useful to you, and I'll see you in my future tutorials.